Hendren. I'm going to be joining the faculty here in the fall of, or next fall, but I hang around here a lot over the course of the next year. So anyway, I'm here to talk about private information and adverse selection in insurance markets. Just to give you a quick overview of what I want to cover today. So first, I want to review a little bit of the literature on asymmetric information and the so-called positive correlation test for testing empirically for the presence of asymmetric information. We'll then talk a little bit about the limitations of the positive correlation test. And then finally, we'll dive into one of those specific limitations in a little bit more detail, discussing how private information can shut down insurance markets. So that's a little bit of the roadmap. So I actually want to start the lecture with some pretty simple definitions that I think can help clarify some of the ideas that people talk about in insurance markets. And so there's, I guess, sort of the sort of motivating definition behind all of this stuff is sort of what is private information, what is asymmetric information. And so usually when we talk about private information or asymmetric information, we're talking about a setting in which an insurance company may not know as much as their potential applicants about what their cost to the insurance company might be. And so does anybody have any particular example that they'd like to share with the class about what might be some source of private information in an insurance market? So I want to start this with a question. Who wants to give an example of some kind of setting where somebody might know something more than what an insurance company might know about what their costs would be? You gonna give the, yeah, go for it.
I don't like to wear seatbelts.
Don't like to wear seatbelts. That's a great one. So that would potentially, for an auto insurer, could potentially raise their costs, and that may not be able to price that out. Anybody want to give another one? What about a health insurance example? Anybody? Yeah. Past diseases, right. So the key assumption that you'd be making to call that private information is that the insurance company would be unable to gather that information to use it to price an insurance. To the extent to which they can't gather full past medical records, some of that information could be used by the applicants to sort of make decisions about what kind of insurance they would want. And so that would be a presence of private information. Okay, so then the second thing that sort of definition that I want to make sure is clear with everybody is the definition of adverse selection. And so adverse selection is sort of a phenomena that's sort of referred to as a characteristic of an insurance contract. And we say an insurance contract is an adversely selected insurance contract if it attracts a non-representative set of the population. So you might imagine that if you took a set of, say, 50, so take one specific segment of the market, so a set of, say, 55-year-old healthy males and consider a health insurance market, we would say that consider a health insurance contract that's offered to these people, that contract would be adversely selected if the costs imposed by the set of people who take that insurance contract are different than the average costs that are experienced by a group of 55-year-old males. Okay? So often we think that adverse selection is sort of a potential manifestation of private information. And the idea here is if people have private information, they can use that information in their selection of an insurance contract, which makes that insurance contract a higher cost than sort of representative of the population, right? So if you know that you don't wear seatbelts, you might be more likely to buy an insurance policy, making that the cost of that insurance policy higher than the average cost for everybody in the group. Okay, does that make sense with everybody? Well, clear on the sort of simple definitions, but they'll I think, come in handy when we go down the road here a little bit. All right. So first, I'm going to review the general theory of asymmetric information. I know Raj has covered a little bit of this, but I'll also push me if I'm going too slow or hold me back if I'm going too quickly. But I want to talk a little bit about sort of the two fundamental papers with the theory of asymmetric information. And these papers sort of shared the Nobel Prize along with Spence's signaling paper. So there's Akerlof's Lemons paper from 1970, and then there's Rothschild and Stiglitz paper from 1976. And so I just want to really briefly walk through the sort of logic embodied in these models and talk a little bit about the differences between them, and then start to think about how then we want to think about doing empirical work in these insurance markets. Okay, So I'm going to think of this Akerlof model applied to insurance, and in doing so, I'm going to rely very heavily on a paper by Einev and Finkelstein from the Journal of Economic Perspectives from 2011, which I think is on the reading list. It's a fantastic paper, but we'll talk a little bit more about it as we go. And so I want to think of just a binary decision on whether to purchase insurance. So what I mean by binary, I mean your decision is, do I buy a specific insurance policy or do I not buy a specific insurance policy? And we want to imagine this world where people differ in their potential expected costs. And imagine that those with higher expected costs may have a higher demand for insurance along the lines that we were just discussing on the previous slide. And so Akerlof proposes sort of a notion of competitive equilibrium in which a price would be a competitive equilibrium if it sort of allows the marginal indifferent purchaser to be willing to cover the average cost of all the people who are willing to pay the insurance policy price. So that was a lot of words, but it's a lot easier to show this in graphs. So what I've got here is just a standard sort of supply and demand type graph in an Akerlof type of a world. So what we're imagining here is people are deciding whether or not to purchase insurance, and everybody has potentially different demands for that insurance policy. And what we're going to do is we're going to order everybody in this world according to how much they want to pay or how much they're willing to pay for that insurance policy. And so when we order people along this axis, so this would be 0 people purchasing the policy, this would be the full market purchasing the policy, and we order them according to their demand curve, according to their willingness to pay for that insurance policy. So downward sloping because we've ordered them that way along the x-axis here. Okay? And so the insight of Akerlof back in 1970 is that people with different demands might have different costs. And so if we draw on the same axis, the costs that these people experience, so this person is willing to pay this price and they have this cost, but the idea is people that are willing to pay less might have lower costs. Okay? And so if we draw out, we can think of this as sort of a marginal cost curve, because on the margin, as you take more and more people into the market, the cost imposed on the set of people, sort of the aggregate cost of that group, is sort of this downward sloping curve given by this marginal cost curve. Okay? Does that make sense? And so what Akerlof says is, well, let's now not think of the marginal cost curve. Let's think of the average cost curve, where fixing a given, say, price here, we would look down and we say, okay, these people are going to be willing to purchase the policy. So let's integrate under the marginal cost curve to calculate the average cost of the set of people who are willing to pay this premium. Okay? And so this generates the average cost curve. And the competitive equilibrium that Akerlof proposes is just one in which the average cost curve intersects the demand curve. So profits are 0 here. So at this point here, this is the sort of competitive equilibrium. Nobody earns any profits because the price is given by this price here in equilibrium. It's enough to cover the average cost of the people that are willing to purchase the policy, and there's no profits left over. Now, the sort of second sort of thing to recognize from this graph is that it's not efficient in the standard sense that we think markets might be efficient. Why is this? Well, there's people here that are willing to pay their particular costs in order to get this insurance policy, but they can't get the insurance because the price, because if they were to sort of lower the price, the set of people, you'd have to lower the price for all these people here who have higher costs. And so that would lead the insurer to not be able to make any profit, make enough profit to cover the losses induced on these people. So there's this sort of welfare loss given by this shaded region, the difference between the demand and the cost, which just calculates sort of a measure of sort of the welfare loss from the fact that you can't tailor the pricing to match the marginal costs. Okay? So that's yeah.
Sorry, I think this is a really stupid question.
No.
So usually you think that in a competitive equilibrium, demand is equal to the marginal cost. And
Yes.
here you exactly explain why they don't set the demand equal to the marginal cost.
That's right.
But that's weird.
Yeah, and that's exactly right. Yes. In a standard world where there's no information problems, we think that you can set prices equal to marginal costs, right? Now, why can't you do that in a world with these sort of information constraints? The reason is you can't find the marginal guy. So you could, if you observed these marginal costs, you could set the price, just right, a competitive market would collapse the price, and you'd have different prices for all these different guys, all priced out at their marginal costs. But the problem is you don't know who these guys are, and so you can't set that price. And so the response of Akerlof is to sort of say, okay, well, maybe we think that insurance companies would just try to set a price so that they could recoup their costs, and that price would be driven down to the point where they have a zero profit condition, but that it's not necessarily going to represent the average, the sort of marginal cost guy. It's going to be the average cost of the group that are actually taking the policy. So yeah, it's a different notion of, I mean, you have to think about sort of a different notion of competitive equilibrium because you can't charge all these guys different prices. Yeah?
Can you talk a bit about like how this generalizes to other settings where we might not have asymmetric information, but nevertheless a falling marginal cost curve?
Well, then you would expect to be able to charge prices tailored to each of the different people. So then you would think of each bin. You could imagine binning everybody here, and you'd have a market within each. You know, you'd charge this guy his price, and maybe there'd be a markup or if you had some monopolistic power. But aside from that, you drive the price down to the marginal cost curve. Does that making sense?
Based on the information, basically.
Yeah, you'd be discriminating within each thing. You know, you'd be tailoring the prices to the risk. Yeah. So in that world, sort of risk adjustment pricing is enough to fix everything. Yeah.
So in a market without adverse selection, the marginal cost doesn't matter for different people. It's the same for different people. Is that?
No, I mean, you could be very, very different, right? Some people could be sick, some people could be healthy. But if that's not private information, then the insurance company can charge the cost of the sick guy. The premiums would reflect the cost of the sick guy. The premiums would reflect the cost of the healthy guy. So sick people would pay more for insurance than healthy people. In this world, there's unobservably sick and healthy people, and they all pay the same price. That's sort of the fundamental constraint is if you don't observe, to the extent to which you don't observe this sort of private information, it can generate this kind of a problem. So it's all. Does that answer the question? Okay. Any other questions? Yeah.
There's one thing I don't completely understand. So the demand curve seems to be really steep, but and drops to very low quantity, but for less than or for more than half of the people at that price, they seem to still be paying a price that's less than their marginal cost. So I don't quite understand why the demand.
So everybody's going to, so yeah, right. So here you're saying the price is going to be below the marginal cost. Yeah. So the idea is that this area should be equal to that area, I believe. I should actually have checked that before I came here.
Is this
Yeah.
just a shift, or it seems like how is the demand curve derived?
So no, the demand curve is taken as a primitive, right? So in this world, you think of the demand curve as sort of driven by a combination of your riskiness and your general preference for insurance. And you think of the marginal cost curve to be sort of the sort of cost of the set of each person.
As in the demand curve is not, it's not directly a mapping of the marginal cost curve.
No, these are two primitives.
Okay.
Yep. And there's no there's not necessarily a needed sort of direct link between them. You can parameterize them in different ways. Now, if you wanted to think of
So what's the main thing in that risk aversion?
so risk aversion would drive demand and also your expected cost. So the combination of those two things would drive your demand. So you could have demand sort of somewhat independent from the marginal cost to the extent to which people are differing in the risk aversion. Yeah.
So the problem in this picture is that the people from Q equilibrium to Q max, they don't have a marginal cost that's low enough to drop the average cost down.
The problem is that you can't charge a price to these guys to reflect their marginal cost. These guys only cost this much to an insurance company. But if I put the price here, these guys are going to say, thank you very much. And they're going to come and take that policy too. And the problem is that would make the whole profitability of the market become negative. This is the point where the profitability of the market is zero.
So in perfect computation, right? So there's also just one price for every type of people.
That's this notion of competitive equilibrium. Yeah, there's one price that would clear.
Here, is it because the MC curve is down?
So, sorry, I missed, what's that? The
Difference here, instead of charging at the marginal cost, is it because the MC curve is downward sloping instead of upward sloping? is the average cost is always went up?
No, you could do it the other way around. So there's, so you could imagine a crazy, not a too crazy, where the people have proposed this is a potential thing going on where the marginal cost curve slopes up, right? Then you would still have an average cost curve that would differ from the marginal cost curve, and it would be the average cost curve that would be generating whether or not where the equilibrium lies. The basic logic is if you just want to, the market price is the solution to a zero profit condition. And the zero profit condition reflects the sort of price times the number of people who take the policy minus the average cost of the people who take the policy. That has to equal 0. And so it's the average, that's just the average cost that's going to matter for the price in equilibrium. Yeah?
Like one thing, so like here we're kind of assuming we have identical insurance companies who all have like the same cost structure, but like the cost is really a function of the individual, not so much of the individual insurance company, right? Because we could think of a world where the marginal insurance company that enters has like a higher marginal cost of providing.
Yeah, no, this is all, I mean, this is sort of in the spirit of the standard sort of models, we're assuming there's like a perfect competition on the insurance side, so you have some set of identical insurers that are providing the same product. Yeah. All right. So is that clear with everybody? So I'm going to push through a little bit now. So this is drawn in a particular way, right? I said these are sort of primitives that, you know, we just can draw these and then say what happens. Akerlof notes, I think most interestingly in his paper, that it's not actually clear that a competitive equilibrium involves any insurance at all. So the market can completely unravel, and this happens if nobody's willing to pay this pooled cost of those with higher demand. So how does this look? Let's draw now, instead of the marginal cost curve being, and the demand curve being above the average cost curve, let's put the demand curve below the average cost curve. Okay? So now what happens, let's imagine we tried to charge a price here. Okay, so we go across here, we say, okay, these people are willing to take this policy. Okay? So everybody to this side is willing to buy this policy. Unfortunately, the average cost of insuring those guys is this. So there's a loss to the insurance company of this size. And they say, okay, well now I got to cover, let's try to recoup these costs. So let's raise the price. Well, now the problem is these guys don't like the policy anymore, right? They're going to say, okay, well, fine, but I'm not going to buy that. And so then they come back here. Well, now you're in a world where you're losing money again. And so you can just imagine this just spirals up to a point where the only equilibrium is one in which there's no insurance provided. So the unique competitive equilibrium in this world is one in which there's no insurance that's provided. Okay? And so whether or not we're in a world like this versus a world like this depends on what the marginal cost and the demand curve looks like. Okay? So it's sort of an empirical kind of a question. Okay. All right. So that's Akerlof. There's another famous paper that takes a little bit of a different approach to thinking about the insurance market and the potential implications of private information. And so Rothschild and Stiglitz, so what were we assuming when we drew that demand curve? We were thinking about a binary decision of whether or not to purchase insurance for a given posted premium. Rothschild and Stiglitz note that there's more things to an insurance policy than just a premium. There's things like deductibles or copays, right? And if you think that people differ in their riskiness, then that should generate not only a difference in their willingness to pay for premiums, but also a difference in their willingness to pay for, in their desire for different copays. And so Rothschild and Stiglitz start to think about differences in sort of what people are willing to pay. And sort of I drew a little bit of a graph over here where you can sort of think about the Rothschild and Stiglitz world. And so you want to sort of think of a world where there's two types. So let's imagine there's a high-risk guy and a low-risk guy. And basically what can happen is there can be a financial loss. Okay, so if there's a financial, so everybody's endowed with some unit of wealth, let's call it W. And if there's no loss, they're able to consume W. But if there's a financial loss, they would have to consume W minus L, which is going to be less than W. Okay? And what I've drawn here is the consumption on the x-axis that they would experience in the event that the loss does not occur, so the good thing happens. And on this axis, the consumption they would experience in the event that the loss happens. And so you can think of drawing the endowment right here as just in the event that the loss happens, you consume this. In the event the loss doesn't happen, you consume this. And Rothschild and Stiglitz sort of look at this world and they say, well, okay, what would we expect an insurance company to do? Okay? So what he says is, he says, well, okay, let's draw the indifference curves, okay? So let's think of a high-risk guy is going to have indifference curves given by some utility function P, let's call it PH, U of CH, plus 1 minus PH times U of C. Okay, so the probability that the loss happens times the consumption that they get in the event that the loss happens, plus the probability that the loss does not happen, times the utility of the consumption in the event that the loss does not happen. And so what happens here is you note that the probabilities here would be different for the high type and the low type, the good guy and the sort of the high risk and the low risk guy. And so this means that they're going to have differently sloping indifference curves. Okay? And so what he says is, okay, let's first think of the high risk guy. The high risk guy we'll draw, let's draw him here. You can think of his indifference curves being sloped like so, and the good risk guy would have indifference curves sloped like this. Yeah?
They're not talking about their parameter of risk aversion, right?
Let's assume they have the same utility function, so they have the same parameter of risk aversion. Yeah. And so the insight here is that low risks are not only less willing to pay a high premium for insurance, but they also are happy to take a higher deductible. Very intuitive, right? They just don't care as much about the state of the world in which the financial loss occurs. So they're willing to give up more money in the event that that state happens. Just referenced by these two differently sloping indifference curves. Okay? And so what do we think might happen in this world? Well, Rothschild and Stiglitz propose a notion of equilibrium where there's sort of a screening outcome. And the insurance companies basically offer two different contracts. Okay? So the first one is going to draw, I'm going to erase these indifference curves just to make it a little bit easier to see what's going to go on. So don't forget those slope differently, but I'm going to erase them because otherwise it's going to get messy. So we can draw the high risk isoprofit line from the endowment to the 45-degree line. And what is this point? This is just going to be W minus PH times the size of the financial loss in both states of the world. So it's like a full insurance contract where you sort of trade your risky endowment for a full insurance contract where you consume your actuarially fair consumption in both states of the world. Okay? We're going to call that the sort of first point. And then he says, okay, we would like, in a perfect world, the good risk guy would consume this point, which would be W minus PLL, which is the actuarially fair insurance bundle to this guy. But the fundamental problem is, if you were to offer this consumption bundle, let's plot the indifference curves of this high-risk guy. This guy would like any contract that you put in this region of the graph. And so if the insurance company said, okay, I'll offer you this contract, this guy would say, I'll take it too. Right? And so you can't offer this contract. And so Rothschild and Stiglitz say, well, okay, but you can't offer this contract. Why can you do this? Because this guy isn't going to take it. This guy, and so what does this contract represent? It represents a sort of higher deductible. This guy experiences a part of the financial loss. He's not fully insured. Okay, so he accepts a contract in which if the loss occurs, his consumption is below the 45-degree line. In other words, he's exposed to risk. Okay? So this is different than the sort of outcome highlighted in Akerlof in the sense of this guy is underinsured as a result of the presence of private information. In the Akerlof world, there are some people that are sort of excluded on the extensive margin. Here, everybody is getting some amount of insurance. Okay? All right. So that's sort of the world. Now, how does anybody want to try to relate the Akerlof unraveling result to this diagram? Can anybody see how you can get a picture that corresponds to this out of this world? Okay. So I'll walk you. Start to walk you through it. So, what happens in this world? Everybody gets 0 amounts of insurance, right? So the market for this insurance policy is sort of unraveled to 0. Okay. So what happens here? We want to see, is there a state of the world where, or sort of a set of parameters for which everybody would be sort of stuck without insurance. Yeah.
You can restrict yourself to the insurance that are aligned.
Okay.
Or like if you have in these lines for
Uh-huh.
you offer insurance and both sides want to take it.
Yeah.
And you keep trying to distinguish to offer lower and lower.
Yeah. So so the first thing you just notice is that you need more than 2 types. Right? So in this world, there's sort of this continuum of sort of types here that we've sort of ordered along. So let's imagine that we've got some kind of continuum of types. Well, what happens? Let's imagine that we try to sell some kind of insurance policy that goes in this direction, tries to get people away from the endowment. Okay? Well, the set of people who are going to be willing to pay this policy is the set of people whose sort of indifference curves are sloped at least this much, right? So if you try to move this direction, anybody whose indifference curves look like this would not take it, but everybody whose indifference curves look like this would be happy to take it because their indifference curve would start moving in that direction. Okay? So the way to think about this Akerlof unraveling result is that for a given movement away from the endowment, there's going to be some kind of cost to that contract that's induced by the set of people who are willing to purchase that insurance contract. Okay? And so what is the cost imposed by a given contract? Well, it's just going to be this sort of the marginal sort of the marginal cost of moving this moving along this direction is going to be given by the set of people willing to purchase this policy. In this sort of simple world, this is just a set of higher risks than the slope. So if we call this, let's move in a direction that makes one guy marginally indifferent. What is the slope of the indifference curves here? It's going to be P u prime of W minus L over 1 minus P u prime of W. This is just the marginal rate of substitution at the endowment. This is type P's slope of his indifference curve at the endowment. Okay. Now, what's the cost to an insurance company of trying to go along this direction? Well, every type P plus all the worst risks are going to try to take that insurance contract in this world, right? Because a set of people here, everybody whose indifference curves slope a little bit more downward, so all the higher risks. And so Akerlof unraveling occurs whenever the average probability, let's call that capital P, for P greater than or equal to P, given P greater than or equal to P. Whenever this marginal rate of substitution falls below the average cost imposed by the presence of those higher risks selecting that contract, whenever this happens for all P, the market unravels. So you can actually see exactly how the adverse selection of Akerlof unraveling can be seen inside of the Rothschild and Stiglitz world. So this is probably not sinking in completely, and it might may not be entirely straightforward, but hopefully if you work out the graph and sit with it for 20 minutes, it should make sense that this is the sort of condition that characterizes when the market unravels in the style of Akerlof. Yeah?
So the right-hand side of that inequality, what is that?
Yeah, this is the average. So imagine that we've got a set of, yeah, that's a great question. So imagine we've got like a set of different risks ordered in this kind of a world. So easiest way to think about it is let's imagine this is their P's. Then the average cost here is just the average probability of the loss occurring for all the higher risks than P. And so there's another way to sort of think of this condition without even thinking about the graph. The left-hand side is the marginal rate of substitution between consumption in the event of no loss and consumption in the event of a loss. Okay? If there was no private information, the actuarially fair cost to a type P of making that transfer would just be P over 1 minus P. Right? But if we take sort of the logic of Akerlof that all the other guys, there's all these other guys that would also demand this kind of a transfer, then the average cost of providing that transfer would be the average probability, which I'm going to call this capital P, of everybody who's a higher risk than P, over 1 minus that average probability. Okay? So that's the right-hand side. So we're going to come back to this a little bit at the end when we talk about testing for whether or not a market is unraveled. But for now, I'll go ahead and push along. And yeah?
So in both of these models, the source of the inefficiency has to do with the low risk type, right? Those people are underinsured or outside the
That's
market.
right, yeah.
Is that, in practice, do we see that? It seems that intuitively we would
So that's the test. So you're exactly, it's a great segue. So that's the essence of the positive correlation test, is do you see a correlation between whether or not there's a sort of the costs imposed to the insurer and the choice of the insurance contract? In other words, do we see that the low risk guys don't buy insurance, or don't buy as much insurance? That's exactly, great segue. Okay. Another term for the positive correlation test is basically adverse selection. So is there sort of this positive correlation between insurance claims and insurance purchase decisions? Okay. So there's a long history of, recent history, I guess, but a long list of papers testing for adverse selection. There's great review articles out there, Cohen and Spiegelman in 2010, and Eino, Finkelstein, and Levin also have a really nice set of review articles that you can go look at. But what I want to focus on today is sort of what's potentially not going to work with this sort of positive correlation test. So does anybody have some intuition in their minds for why we may not observe a positive correlation between insurance purchase and insurance claims in an insurance market, aside from the reason that there might not be any private information? Yeah? Different willingness to pay, so preference heterogeneity. And so walk through how that might pose a problem. So, yep. No, absolutely. So in health insurance, David Cutler likes to refer to these people as the worried well. They're fantastic people for insurance markets, right? Yeah. So how about another reason that we might not think the positive correlation test? I'll go ahead and I'll go for it. What's that? Moral hazard. So so that's a case where what would happen?
So you do observe this positive correlation, but it's not because of asymmetric information.
Yes. Great. Absolutely. Right. So the positive correlation test is a joint test for moral hazard and adverse selection. Right. So you can't get around that issue very easily. Yeah. Any others? Sorry, I shouldn't have flipped this slide. I think there were probably other things you guys would have said. But okay. So there's a great point raised. Point one was just raised. So it doesn't account for sort of other dimensions of heterogeneity that might confound the positive correlation. So there's this literature on advantageous selection. For example, Finkelstein and McGarry have a paper that we'll talk about in a second. Now, second, there's also an issue with the positive correlation that not only do we want to know if there is adverse selection or private information, we also want to know whether or not we should care about it, right? Or should we do anything about it? And the fact that higher risk people purchase more insurance doesn't necessarily say how bad of a problem that is. So you could have a stronger correlation between insurance purchase and insurance claims, but it's not clear that actually leads to higher welfare losses. So for example, it doesn't mean that shaded gray area of that Akerlof triangle or that Akerlof demand system there doesn't necessarily have to be bigger if there's a higher correlation. Those aren't necessarily related. And then, so finally is sort of an issue that we were just talking about that we'll talk about towards the end, which is that you may not observe a positive correlation if people aren't offered any contracts to begin with. So if you think that the Akerlof world, the unraveling world, is actually what's happening, then you just wouldn't see the market at all, right? So you wouldn't see, so private information is just then in that case not being manifest in the form of adverse selection or a positive correlation. It's instead just causing the market to not exist. Okay. So those are the three limitations I think that we're going to try to chat through here for the rest of the hour and a half. So I'll start with the first one. So preference heterogeneity and advantageous selection. So the standard theory, going back to Rothschild and Stiglitz, is that people differ primarily in their risk type. So people have just different expected costs to the insurers, and they know their expected costs. But in reality, as was mentioned, people are different in many other ways too. So you might imagine that you've got these worried well people, and so that if there's these worried well people, they might make sort of the market look a little bit differently than if people were only differing in their risk type. And so this actually could lead to advantageous selection if you imagine that there's a sort of substantially negative correlation between your risk preferences and your risk type, so that the low-risk guys really, really, really want insurance. You could imagine that those guys might be the only people that buy the insurance, right? So then you'd only have the low-risk guys purchasing the insurance, and then the high-risk guys are like, I'm living on the edge. I don't have an interest in buying this insurance policy. So you might actually see advantageous selection in a world where there's heterogeneity in preferences of that sort. Okay. So there's two recent empirical papers trying to find evidence of preference heterogeneity and evidence of potential advantageous selection. So the first is this Finkelstein and McGarry paper. They document basically heterogeneity in preference parameters that are things that are unobservable to the insurer, like seatbelt use, are correlated with their demand for insurance. So the idea, this worried well idea, is that there's people that have these preferences that matter for that matter for their demand for insurance, but don't necessarily affect their riskiness. So for car insurance, seatbelt use is sort of a factor that would potentially affect or be related to your expected claims. But for long-term care insurance, which insures you against going to a nursing home, it seems more reasonable that seatbelt use is sort of more of a preference parameter, sort of a risky person versus a not so a risk-loving person versus a not so risk-loving person. And so they suggest, so it turns out in long-term care insurance that there's this sort of surprising fact that people that buy long-term care insurance aren't more likely to go to a nursing home, conditional on the observable characteristics insurance companies price the insurance policy with. So one interpretation of that is that people don't have private information. Another interpretation is that there's two kind of counteracting forces, where there's this sort of potentially these worried well people who are helping to sort of keep the market from being too heavily adversely selected. There's now another paper by Hunmin Feng, Keen, and Silverman in the JPE from 2008, and they document advantageous selection in Medigap. So Medigap is a market for supplemental insurance for people on Medicare. So when you turn 65, you get Medicare, but that covers about 80% of your costs. So there's still a co-insurance associated with Medicare. And what Medigap does is it allows you to purchase policies to cover that sort of remaining gap. So hence Medigap, right? So what they document, quite surprisingly, is that the set of the people who buy Medigap are actually lower cost than the people who don't. Right? And so then they try to say, well, why is that? And what they do is they see, well, we find these other characteristics that are both negatively correlated with your risk type, your cost to the insurer, and positively correlated with your demand for insurance. And what is the thing that they find? Well, they find cognitive ability. So basically in the health and retirement study, there's these measures of how with it you are. So this is it's a study that sort of asks people, how they try to get at sort of how cognitively with it are you. And what they basically, I don't know, I'm trying to find a better, I should have thought of a better word than cognitively with it. But it's basically like how well you can, they ask you a bunch of sort of questions about, like they do word recall tests. Like, can you remember, like they give you 10 words and then they wait a while and they ask you, oh, what were those 10 words? And it's sort of measures of cognitive ability, right? So how good is your memory? And so basically what they're documenting if you kind of want to put it in a very simple one-sentence word, is that there's some people that have low cognitive ability, so like people with dementia, and they also, they have high costs, so they're sick, but they also choose not to purchase Medigap. Okay? So this is a violation of sort of the standard, everybody has the same utility function theory from Rothschild and Stiglitz, because there's some people that have sort of cognitive limitations, and that leads them to not purchase insurance policies, even though they're high costs. Okay. So that's sort of a couple of recent papers, and there's a lot of ongoing research on preference heterogeneity in insurance markets and trying to understand, what's the relative role of preference heterogeneity versus heterogeneity in risk types and your sort of expected costs. Yeah.
So is this like advantageous selection, just all saying why the demand curve might not be like below the
Yeah.
average cost curve? Is that it?
It's all basically saying why this may not be as downward sloping as you might have thought. Why it might be, yeah.
I mean, is it saying just that is why we're not in this case at all? Or?
Nope, it's saying why we're not even in this case.
Okay.
Right? So what it's saying is, in this world, this is adverse selection. Why? The low risk guys don't buy the insurance. The high risk guys buy the insurance. The higher cost guys and the lower cost guys. What they're showing is, or maybe there's a world where this is either flat because of sort of two offsetting factors, or maybe even increasing.
And then in that case, is the average cost, I mean, are you still pricing with the average cost curve, but then it's upwards?
There's a lot of interesting theoretical debate about what clears the market in those worlds. So in the standard Akerlof world, yes, there's some work by Bernard Slanier who argues that there's some kind of more fundamental problems with pricing and average cost in those settings. But yeah, that's in the simple world, yes. All right. Okay. So that was the first sort of limitation of the positive correlation test. The second one is that positive correlation doesn't really tell us how bad adverse selection can be. So a larger correlation doesn't imply larger welfare losses or greater distortions in the market. And so what you want is really a framework for evaluating welfare losses. And so there's a bunch of papers that kind of try to do this. Yeah, you have a question? Oh, just stretching, sorry. Yeah.
Just in these correlation tests, how do we go about the magnitudes of these correlations anyway?
Yeah, it's really just a test, right? So you try to reject the null of 0. Yeah, that's exactly the problem, right? Is that really what you want to know is maybe what's the value, what would be the increased welfare if you remove the informational asymmetries, or what's the sort of marginal welfare loss from the distortion in pricing, these types of things. And the correlation test doesn't tell you that. It just tells you whether or not there might be a problem. And then also it doesn't distinguish between moral hazard and adverse selection as well. So what these papers, or this line of literature tries to do is say, well, let's try to actually estimate how much of a welfare loss there is from the adverse selection.
Isn't that one of those cases, I mean, if we had enough data, we'd always reject them all.
Yeah.
So
Yeah, one way or another, unless you have some crazy, yeah. I mean, that's sort of, you can say that about a lot of statistical tests in economics.
I mean, since this one doesn't
Yeah.
have any quantitative interpretation.
Yeah. Yeah. It's very concerning when you run a test which doesn't allow you to compare across two tests, right? So a positive correlation test in principle doesn't actually let you compare two groups of people and say this one's worse than this. All you're doing is, because you can reject the null in one and not in the other, but still have a higher amount of welfare loss from adverse selection in one than the other. It could just be the sample size is driving your estimates of the p-values. Yeah. Great point. Yeah.
So does the larger correlation really mean any, like, is there any interpretation at all to the correlation?
So
It could
unless
be-
you
it could be
assume
like
some
a
kind of
non-trivial
structure.
relationship.
So you have to put some structure in the problem to get it to mean something, right? So it's just, in general, it's just a correlation. You have to have some kind of and without any additional stuff to tell you why that correlation arised, it doesn't map directly into welfare measures. But there are ways of sort of thinking about it a little bit differently. So now I'll talk you through kind of how you can actually sort of think through how sort of a marginal correlation can correspond to welfare. And I'll show you that now. So one of the particular, I think one of the nicer papers recently that does try to sort of clearly map estimates, sort of reduced form estimates of sort of not a positive correlation, but sort of well, It's like a positive correlation. I'll show you. But tries to sort of get at the question of what's the welfare loss from adverse selection. And so this is a paper by Einhoff and Finkelstein in the Journal of Economic Perspectives. Actually, the actual welfare estimates come from a paper that they did with Cullen in the QJE in 2010. But the basic model is, suppose there's two insurance contracts. So just go back to the binary world of Akerlof, and just assume that the choice that people have is to get a plush policy, a high coverage policy versus a low coverage policy. And let's just model that binary decision. So agents just choose the high coverage policy or the low coverage policy. So P is then going to be the relative price of the high coverage policy versus the low coverage policy. D of P is going to be the demand curve, so the fraction of people who purchase H instead of L at a given price. The average cost of P is going to be the average cost curve, so the average cost experienced by the set of people who are willing to purchase the policy at price P. And the marginal cost curve is just the price for the person who is indifferent, or sorry, the cost for the person who is indifferent to paying P for that policy. So the marginal guy's cost. Okay. So now you can draw those same graphs before. This is basically the same graph that we had before, with just a sort of slight difference in the demand curve in the location of the demand curve in the marginal cost curve. And so here we've got the demand curve. We've got, again, people are ordered according to their demand, and then the resulting marginal cost curve in a world where there's now, since it's downward sloping, there's potential for adverse selection here. The equilibrium price equates the average cost curve to the demand curve. So these people would be willing to purchase the plush policy. These guys get the low coverage policy. The efficient allocation here would be the setting where people paid, where you provided insurance to everybody who was willing to pay their own cost. So the efficient allocation would be this point E. And so you can think of the shaded region. This is basically the same shaded region that we showed you before in the beginning of the talk, but this is sort of the difference between the willingness to pay for the insurance policies and their own marginal costs to those insurance policies. So these are sort of the welfare loss from the adverse selection. And so in this world, you can actually represent the welfare loss as just the difference between the demand curve and the marginal cost curve between the points where the market is actually in equilibrium and the point where it would be efficient to provide those insurance contracts. Okay. So the goal of Einhoff and Finkelstein's paper is to estimate this, is to turn this graph into an empirically estimated object. And so what do you need to estimate this graph? Does anybody see, I hinted at it because I turned the slide, but does anybody see what you actually need to estimate this graph? This is, I think, one of the more surprising things out there.
You need to know the shape of the demand.
Need to know the slope of the demand, yeah, you need to know the level and the slope of the demand curve. And what else? Marginal cost or maybe the average cost curve, one of those two, because they're linked, right? You just take a derivative or integrate, right? How would you estimate it? What's the type of data variation that you need? Prices. What do you need? You need random variation in prices, right? So in other words, we need to assume we're not at a competitive equilibrium. The prices are not coming from this point here, but rather they're given from some external sort of crazy choices that may not represent choices that come from this point. Okay. So how does the, yeah?
The marginal cost curve, that would be extremely hard to back out even then, wouldn't it? To know who's the marginal person.
Yep. So this is the beauty here is if you have random variation in prices, then what you can do is you can say for any given price, what's the set of people who are willing to pay that price? So if you observed a world where that price was posted and then you went and looked and said, okay, these are the people who bought it, then you can say, what is the average cost of those people? So now we're just mapping out the average cost curve, right? So in this world, you can identify both the demand curve, the fraction of people that purchase the policy at any given price, and also the average cost curve by just observing for each world where there's a different price posted, what's the average cost experienced by the set of people who actually choose that insurance contract. Does that Sync? Okay. So
Ignoring moral hazard as well.
it actually, so it doesn't ignore moral hazard in the sense of there could be a fact that people select the insurance policy knowing that if they get the insurance, they would choose to consume more things of higher cost. But that would be factored in the sense of, because we're varying the price, we're analyzing who selects it and what's the cost of the people who select it. So then we're estimating the average cost curve for the set of people who choose the insurance policy. So we're actually not, so the moral hazard is the causal effect of the insurance policy. There may be some underlying causal effect of the insurance policy on the cost, but because we're just sort of posting the price and saying who selects, what we're estimating is the average cost curve on the set of people who purchased the policy. And so as you vary the price, you're not varying the moral hazard piece of it, you're just varying the set of people who select into it. And so you're getting the average cost curve for the insurees. Now, with moral hazard, there may be another cost curve for the non-insured people, which would be different because people make different choices if they're not insured. But in this case, we can get the average cost curve for the insurees, which turns out to actually be the precise thing that you want in order to capture the welfare loss from adverse selection in this world. But in the paper, in the JEP paper and I think the TJE paper, there's a discussion of moral hazard and draws those different curves. Yeah?
So the reason that you get both supply and demand with one price change is because the different people who select into it.
It's because we have a fun notion of what supply is in insurance. Right? So supply is sort of the average cost of the set of people who demand it in this world. And so because that's what we are going to assume is sort of the supply curve, then we can get that because it's intricately related to the demand curve. It's a function of the set of the cost characteristics of the set of people who demand it. So yeah. But yeah, it's a nice thing with insurance is that there's not really any production going on here. It's just moving money around. Yeah. Right. So so that's going to be a limitation of this approach is that there's really just analyzing a binary decision about high versus low coverage, and so that kind of leads into so what's the institutional structure that they study in this paper? They look at Alcoa. So this is a company that makes aluminum, and they have different business units where the business unit heads choose the price of the PPO versus the HMO, or actually I'm not 100% sure that it's PPO versus HMO, but of the plush policy versus the less generous policy. And so because of their institutional structure that they're considering, there really is, the primary decision is really just a binary decision between more coverage versus less coverage. And so they map that into the sort of theoretical world of the Akerlof type environment. But in general, in insurance markets, there's all kinds of policies, and so it's not necessarily going to speak to adverse selection on other types of policies or the characteristics of the insurance policies that are offered in equilibrium. So they get data. They look at the different costs and demands experienced by the different business units and plot it on the exact same graph given by the theory. And so here you get the average cost curve. So these black bubbles are just the average costs experienced by the different business units that chose different prices. So here you see that this business unit experienced this relative cost, and this was their chosen price difference. And then you just sort of plot these differences for each of you plot each of these numbers for the different business units, and you can see the sort of circles here are plotting the fraction of people that are purchasing that policy, so sort of the demand curve, and then the average cost curve is the average cost experienced by the set of people that are actually demanding the policy. Okay? And so now you get this shaded region here, or not shaded region, but you could shade it in. That's the sort of welfare cost from the presence of adverse selection, from the fact that the pricing is inefficient to these guys, that you would have liked to price at the marginal cost curve, not the average cost curve.
Sorry, I'm confused because since the price is given exogenously,
Yeah.
so like we have these points that are beyond and before the
Yeah.
equilibrium point.
Yeah.
So this is not going to be the total inefficiency of this market. It's just the
No.
due to the.
That's absolutely right. So it's a great point. It's not even going to be close to the inefficiency driven by this market because in practice, these guys are charging prices that are constant for everybody within the group. And we know that that's probably really, really inefficient as well, right? And it's not going to capture that. But what it is going to capture is the welfare loss from inefficient pricing at the group level. So the precise hypothetical that you want to think of is, let's imagine that instead of allowing the business unit heads to choose the price, we allowed a market to choose the price, and it equated it to the expected cost, to the average cost curve. So then we would observe this point. Then we could ask, how inefficient would that competitive equilibrium be relative to a world where they were able to charge marginal prices equal to their business unit marginal costs? And so that would be this circle here. But I should have been clearer on what the sort of precise counterfactual welfare experiment is in the paper. Yeah. Okay. So the results kind of suggest that the welfare loss is small. I mean, this depends on your sort of interpretation. So the size of that triangle is about $10 per employee, which is about 2% of the average price. So it's a nice paper in the sense of it's always good when you can draw a theoretical graph and then actually just estimate and show the exact same graph. But I think that, as you guys have mentioned, there's some caveats worth noting. So the welfare loss is really just is estimated off of the inefficient pricing at the business unit head, or at the level of the business unit head. And so there's many reasons to think that you would have rather had pricing to be individual specific as opposed to just aggregated at the business unit head. And also from Rothschild and Stiglitz, we know that perhaps some of the inefficiency is given by the fact that the wrong contracts are actually in existence. So there might be, so it might not be the case that the plush contract is the efficient plus plush contract. You might have wanted to have, in a sort of a first best world, you might have wanted to have a richer insurance contract that provided more insurance, but because of the potential presence of private information, they chose to, maybe chose to offer a less generous insurance contract. There's also issues of generalizability, as there is with any paper. So this is, Alcoa is largely a bunch of productively employed upper middle class people. It's also a group kind of insurance market, not necessarily like an individual insurance market, so it's not clear how the differential selection would map if you wanted to think about individual insurance markets as opposed to people that get their insurance through their employer. And then it's also sort of an intensive margin decision of sort of more versus less insurance. It's about getting the plush policy versus the sort of standard policy. And it might be a different kind of a world than if you wanted to consider the welfare losses from the decision to buy any insurance versus no insurance.
Do they have the panels here or just a cross-section?
They have panel data, but that paper I don't believe uses, I should know whether or not it uses panel data. I don't believe they use panel data in that paper, yeah.
So,
Do you have something in mind about what they?
Well, I mean, if they acquired some information about themselves, they might switch.
Yeah, so some dynamic sorting, yeah.
Indicate some sort of selection.
Yep, yeah. All right, so that was the second limitation. So the third limitation that I'll talk about is a little bit closer to my own research, but this is really talking about kind of the difference, what we said in the sort of the first slide, the difference between private information and adverse selection. So there's this general impression that suggests adverse selection may not be a big sort of issue with insurance markets. So there's a lot of papers out there finding evidence of some adverse selection, but in general, the welfare estimates are found to be kind of small. So that $10 per person is sort of not a sort of outlier in the size of welfare estimates that people have found. But there's this sort of question about whether or not adverse selection is the right thing to look for, right? So if you believe the sort of Akerlof world where unraveling is possible, it might just be the case that there's a lot of sort of potential insurance markets that could exist out there that we just don't see, right? So that's sort of a potential issue. And then in those worlds, you wouldn't observe a positive correlation between insurance purchase and insurance claims because there was no insurer to begin with. And so that might have different welfare losses than the welfare loss on the actual existing insurance contracts. So in a paper that I have been working on, I characterize when private information leads to sort of adverse selection. And so the condition that I work through here, sorry, just lost this thing. Said I wasn't used to the microphone, but all right. So the condition that we were talking about over here turns out to be the condition in which you can sort of say whether or not trade would occur. I'll go ahead and maybe you guys probably can't see it very well over here, but I'll write the condition again. So the environment is sort of straightforward. People have some initial endowment W. They face a potential loss, so they're either going to consume W or they're going to consume W minus L. Okay? They have utility function given by P, where P is their privately known probability that this loss is going to occur. So P times the utility of consumption in the event that the loss happens, plus 1 minus P times utility in the consumption in the event no loss happens. Okay, so that's their utility function. And then the question is, when do we get sort of an Akerlof type of unraveling in this world where you wouldn't expect any trade to occur, where you'd expect the market to just not exist? And the condition that I was alluding to before is that you can just sort of think of exactly the sort of Akerlof logic. So let's imagine trying to give everybody give somebody a small insurance contract. So just try to move money between the event that the loss doesn't happen and the event that the loss does happen. The willingness to pay for somebody to move money across states of the world is given by their marginal rate of substitution between those two states of the world. Okay? So what's the marginal rate of substitution for somebody in this environment between consumption in the event of no loss and consumption in the event of a loss, evaluated at an endowment? It's just going to be P times U prime of W minus L over 1 minus P times U prime of W, right? This is their willingness to pay for money, or transferring resources across the state of the world. And if, as I was saying earlier, if this is less than or equal to the average probability of all the worst risks over 1 minus that average probability, then the market would unravel. You wouldn't see an insurance contract that would provide any insurance against the occurrence of that loss. Okay? So basically what I was writing on the slide, whenever the sort of willingness to pay for insurance is just not big enough to overcome the hurdle by adverse selection, you would expect the market to not exist. So there's sort of two numbers you can think about for whether or not a market would exist. One is sort of the inherent willingness to pay people have for insurance. The other is sort of the hurdle imposed by the presence of private information. Okay? Yeah.
Can I ask?
Yeah.
Which P is which P?
Yeah.
Are those
So
all big P's except for the...
So this is a little p, this is a little p, this is a little p, this is a little p. This is a big P, this is a big P, this is a big P, this is a big P.
Okay.
So why do I have little p's and big P's? And why didn't I define it? I didn't define it because I was not being generous and I should have defined it. Why are they big P's? So a big P is like a random draw from the population. So it's like a random variable. So the way you want to think about it, let's imagine everybody in this room has different probabilities with which this loss will occur. If I just randomly drew somebody from this population, I'm going to call that random variable P, capital P. A particular realization would be a lowercase p. So this is like the lowercase p guy's utility marginal rate of substitution. But this is the average cost of providing this insurance transfer if all the worse risks than P were to select that contract. Is that making some sense? Okay. And so the unraveling condition is just that this has to happen for all P. Okay. And so you can rewrite this condition, and it makes it a little bit maybe easier to sort of see what's going on. If you just multiply by 1 minus P over P, you end up with U prime of W minus L over U prime of W is less than or equal to 1 minus P over P times the expected value of capital P given capital P is greater than or equal to little p over 1 minus expected capital P given capital P is greater than or equal to little p. And this is sort of a number which is like the markup that's imposed on the type P if all the worst risks are selecting that insurance contract. So sort of the average cost that this guy would have to pay in order to make this insurance contract break even. Okay. So now you can think of this as sort of the markup that's imposed on insurance contracts by the presence of private information. And you can think of this as the markup that people are willing to pay for insurance. Okay. So this is like, if you think back to the Bailey formula, if you guys talked about unemployment insurance, this is like your willingness to pay for some unemployment insurance. And in the unemployment insurance model, you contrast this with the duration elasticity, the cost imposed by increasing unemployment insurance benefits. That's a world where moral hazard is your fundamental constraint. In this world, private information is sort of the fundamental constraint, and this number characterizes the barrier to trade imposed by private information. Okay.
So then we think that risk aversion helps us in this market if people are really risk averse?
Exactly. So if people are more risk averse, you would expect the insurance market to be more likely to exist because it can overcome the hurdle imposed by the potential adverse selection. They're willing to cover the costs of those higher risks. Yeah.
So that 10 sec gets bigger.
Yep, so if this is a bigger number, you're more likely to see the market exists. If this is a bigger number, you're less likely to see the market exist. And so now I'm going to walk you through in like the last 15 minutes about how you might estimate this number. All right. So the setting that I consider, yeah. That's right. Yeah. Or a mixed distribution. Yeah. Some random variable. Yeah. So I'm imagining. So the condition is that. So let's walk through what this condition says. So let's imagine I'm an insurance company, and I'm going to try to sell you guys insurance. Okay. You all have different little p's, the probability with which that loss will occur. Okay. What this condition says is, okay, let me try to sell you an insurance policy. Okay. And let's say you're. So I'll do it. The cheapest way for me to do it is to make you perfectly indifferent to it. Okay. But now, if you're indifferent to it, all the risks worse than you are going to want that policy too, in this sort of stylized world. Okay. So what's the cost to me of selling you that insurance, or of giving you giving you this transfer? It's the average. It's given by the average probability of all the worst risks than you, and the cost of the transfer is then the average probability of all the worst risks than you over 1 minus that average probability. Okay. Your willingness to pay for that policy is given by p over 1 minus p times u prime of w minus l over u prime of w, because on the margin that's your sort of your margin rate of substitution between those two consumption states. Yeah. And so the sort of condition here is that if nobody in this room is willing to pay that average cost of those worst risks in order to get some insurance, then there's not going to be any insurance market. The market's unraveled in the sense of Akerlof. Cool. All right. So the setting that I consider in my own work is insurance rejection. So there's a lot of people can't buy insurance policies. So insurers sort of reject people because they have certain observable, often kind of high-risk characteristics. So, so for example, like in a long-term care insurance, if you've had a stroke, even if you're 55 years old and otherwise healthy, you're no longer going to be able to buy an insurance policy that would provide you money in the event you go to a nursing home. The insurance companies are like, we're not going to deal with you. We're going to turn you away. Okay. And so there's a lot of policy interest with these so-called sort of pre-existing conditions and rejections. So even Romney was willing to try to do something about these pre-existing conditions. And so what do I do in my own paper? Well, I just imagine that let's try to see whether private information is causing these rejections. And so how could it be causing these rejections? Well, I want to imagine that for those whose characteristics prevent them from being able to purchase insurance, the market is unraveled in the sense of Akerlof. People aren't willing to pay the average cost of worst risks in order to get some insurance. Okay. In contrast, where the market exists, we would expect the market not to have been unraveled, right? And so that's sort of the idea. Yeah.
If the insurance company wants them, could they charge a very high price for this?
That's right. Yeah. In long-term care, life, disability, and health insurance, there's no restrictions on what characteristics they can use to price the insurance aside from race, and so they're able to adjust prices to reflect risk. Right. Right.
So if the market doesn't exist, necessarily because they think they have extra money.
So that's going to be the theory that I try to test, is that it's not just that somebody had a stroke, it's what they also know now that they've had a stroke. Mm-hmm. All right. So this is an underwriting guideline to show you kind of what rejections looks like. So this document is from Genworth Financial, one of the largest long-term care insurance underwriters in the United States. And what this document has, it's got about 150 pages, and you open it up, and it's just got a list of conditions that they say, okay, we're not going to sell insurance to people with these conditions. Okay. Yeah, so basically the insurance agents are instructed if somebody shows up to just say, go home. So what do we need to do to say whether private information is causing rejections? Well, we need to estimate private information for those who can buy insurance and those who can't buy insurance, and then say something about whether or not we think that sort of condition is holding for those who can't buy insurance and not holding for those who can. And so the difficult thing is that we need to estimate sort of demand curves, or we need to estimate sort of what people know about their risk that insurance companies don't know. We want to find out this private information, but we can't use a positive correlation test because insurance contracts aren't offered in the first place. And so the solution that I propose is to use subjective probability elicitations. So this is basically just asking people, what's the chance some event's going to happen to you in the future? Okay? So for a long-term care setting, you ask, what's the chance that you're going to go to a nursing home in the next 5 years? Okay? Now, the big question with this is, do people report their true beliefs? Right? So you might imagine there's a lot of problems with just asking somebody, you know, what's the chance some event's going to happen to you? And so what I've plotted here, this is a histogram of the responses to this question, and what you can see is the most common response is 0. So why would we be unhappy with a response of 0 as a measure of true beliefs? Anybody want to take a stab at why that's sort of, you can immediately say that's got to be crazy? What's unique about 0? It implies an infinite willingness to pay for an insurance, for a contract that would pay you money in the event that you'd be willing to give up sort of an infinite amount of resources in the event you go to a nursing home. You don't care, right? So more likely, it seems like people just aren't reporting sort of what they think are actually sort of their probabilities that are governing their behavior. Right? There's also some evidence from psychology that sort of shows the way you frame these sort of subjective probability elicitation questions can dramatically affect the answer. So if you don't make it a free response, a lot of these sort of concentrations at 0 and 50 go away. So it sort of suggests that these aren't really good measures of beliefs. The only reason I want to say is sort of say, and so then the goal is to sort of say, what can we do if we're not willing to assume that these are true beliefs? And so everything actually that I do would go through if these actually were true beliefs and you believe the assumptions that I'm about to make. But it's just going to allow us to relax the assumption that people are actually reporting true beliefs. And so what I would do is impose sets of increasing assumptions about what these subjective probability elicitations are. So some minimal assumptions are going to allow for a test for the presence of private information, and some stronger assumptions are going to allow for sort of a quantification of this sort of price of market existence, sort of the right-hand side of that equation over there. And so I think this highlights sort of a general trade-off in empirical work, that you always want to get a number that's really close to the theoretical conditions that you're trying to test. But often trying to get something closer to what you actually want to test comes at the expense of having to make additional assumptions that you may not believe. And so you try to sort of walk, hopefully, along the line of making the sort of minimal set of assumptions that you need in order to ask the question that you're interested in. So what do I want to assume about these elicitations? Well, I want to assume that people have some beliefs that are governing their behavior, but that the elicitations may not be those actual beliefs. Instead, the assumption that I'm going to make is that elicitations contain no more information about the loss than would true beliefs. What does this mean? So the easiest way to think about the assumption that I'm going to make is that if Z, oh God, I haven't defined Z. If the elicitation, so what people are responding to this survey, contains information about whether or not the corresponding event actually happens, then I want to be able to conclude that so would their true beliefs. In other words, if you tell me, if I ask you, are you going to go to a nursing home? And then you tell me something that's predictive of whether or not you actually go to a nursing home, I want to be able to conclude that you actually knew something about whether or not you were going to go to a nursing home. This is the assumption that allows one to draw that conclusion. It's an assumption that you can't tell me something you don't know. Okay? Under that assumption, there's a natural test for the presence of private information, which is just to ask whether people's elicitations, so whether or not what they're responding to in this question, are predictive of whether or not the future event happens, whether or not somebody, say, goes to a nursing home, conditional on the observable information insurance companies could use to price the insurance policy.
Do something when that's not what I really believe.
On average, great question, yeah. So in principle, it's sort of within an individual, but when you actually implement the test, you're going to always look at sort of averages, and then the conclusion is that you're testing for the idea that somebody within the market knows something. Within the set of whatever you aggregate up to that group, if you reject that null hypothesis of no predictive power, then you know that at least somebody in there was able to predict a little bit. Okay, so the results. So this is sort of a measure of predictiveness of these subjective probability elicitations for 3 different samples of people. So the set of people who can't buy insurance, the people who would be rejected based on their observable characteristics, the people who can buy insurance, the people who would not be rejected, the difference between them, and then also a set of people who are unable to be classified into whether or not they can buy insurance for some data limitation reasons. So I think the thing to note is that in sort of the sort of 3 markets that are considered in the paper, so long-term care insurance markets, disability insurance markets, and life insurance policies, And so the result suggests that there's private information held by those who are unable to purchase insurance in all three of these markets, but smaller amounts of private information held by those who are able to purchase insurance in these markets. Yeah.
What's that outcome variable? Like, what's the
Yeah. So so what you want to think of, the magnitudes are probably too long. Since I only have 5 minutes, the magnitudes are actually going to be really difficult to interpret. But they're lower bounds on measures related to the right-hand side of that equation. The statistical significance tests are just asking whether the subjective probabilities are predictive. So the 3 stars here is basically saying that the subjective probabilities are significantly predictive at the 0.01 level. And then that this difference is positive at the 0.01 level. Yeah. Predicting the corresponding event. So for the long-term care setting, we're just ask somebody what's the chance you're going to go to a nursing home in 5 years, then ask, does that predict whether you go to a nursing home in 5 years? Track them, yes. Panel data, yes. Yeah. Ooh, sorry, I was not making that clear. Yeah, so it's panel data. And you're just asking, are people predicting these future events? So yeah, the whole idea is to use the panel and say, can people predict these future events that are going to happen to them? Yeah.
For disability, do people actually sign up for disability insurance?
There is a private market that covers about 35% of the U.S. population through group and individual markets. Yeah. But there is like a supplement. I mean, the government is very heavily involved in the disability. I mean, SSDI is a primary source of disability insurance. Yeah. But what you want to think about is this is sort of the individual, like an individual insurance market, sort of what this is corresponding to. Yeah.
the sample for rejected people? Were they rejected before or after the
In all likelihood, they never applied, right? They have characteristics that would prevent them from being able to purchase
Okay, so
insurance.
it's based on the purpose.
Most people don't apply, right? So if the insurance agent was doing their job, this person didn't apply. Yeah.
So, I mean, the insurance company can't take this into account with higher prices just because that condition doesn't hold? I mean, because I can understand that
Yeah.
you're showing that.
The question is, like, why can't they raise their price for those who would be rejected, right? And what this is showing is that within the set of people that say have had a stroke, there's differences in the chance in which they're going to go to a nursing home and that they know, right? And so the question is that this establishes just the presence of differences. I think what your question highlights is it enough of a difference to explain why you can't just increase that price and cover that cost? Are we actually unraveling in the sense of Akerlof? And that's sort of a question that we can sort of skip ahead to. So for that, you actually need to know the full distribution of these probabilities. So you can sort of think in the Akerlof world, you want to know the whole set of the demand curve, right? And so then you can sort of ask how much of a markup would people have to be willing to pay in order to overcome the hurdle imposed by the presence of higher risks adversely selecting those contracts. And you look across the population and you search for the minimum. And that's sort of a number characterizing how costly the adverse selection problem would be if they were to open up this insurance market. And so what this number here suggests is that if an insurance company were to try to sell a long-term care insurance policy to somebody who is currently rejected, they would lose money on average unless people are willing to pay an 82% markup for insurance. Okay? Does that make sense? Conversely, where they're actually selling insurance, they can make money as long as people are willing to pay a 16% markup for insurance, which is statistically insignificantly different from zero. So the idea is that where the market doesn't exist, there's a lot of barriers imposed to constructing a market because of the presence of private information. Yeah. That's the difference here, right? So these are the set of people who can buy insurance. So this would be like a market for healthy people, and this is the market sort of for sick people, more or less. So it's like no, I think you exactly this is exactly sort of the comparison that you want, and then the difference is the difference in these markups. And so what's nice about these numbers is you can interpret them in terms of a willingness to pay for insurance, sort of like how much do people have to be willing to pay to start up the market. Okay, so I skipped through a lot of stuff, but since we've just got 30 seconds left, let me actually just skip to the last thing that I think is maybe worthwhile talking about, sort of what might you be interested in for thinking about future work in this area. So I think there's a lot of interesting stuff one could think about in group versus individual markets. So there's a lot of reasons to think that if adverse selection or private information is a problem for insurance markets, There's a lot of reasons to think that they're differently, that those problems are different for group versus individual insurance markets, and that you might have reasons to think group markets do better, or in some cases maybe worse than individual markets. And you could imagine, how do people form group markets? So anybody who's interested in matching models in the spirit of Al Roth's Nobel Prize might be interested in thinking about something like that. There's also questions outside of directly public finance, but questions about what happens in financial markets in sort of the role of asymmetric information in other financial markets. So if you remember the credit freeze, you had credit markets that just evaporated overnight. So these sort of asset-backed securities, sort of the markets for retrading these things just completely evaporated on the day after Lehman collapsed. And so thinking about what are the, is this private information? Is it other types of things that are generating these markets to collapse? Is potentially some interesting things to think about. And then finally, sort of issues of dynamics. There's a lot of work in insurance on sort of the static question of what's the relationship between purchases and claims, and what's the demand for insurance. But there's also, I think, a growing recognition that trying to focus on the role of sort of when to purchase insurance and sort of what age should you be thinking about purchasing insurance, and what happens as your risk evolves over your lifetime. How does that affect the insurance markets, or things that maybe you want to think about. But thanks, guys, for your time. Thanks for having me.